Okay, the 2019 trigonometry question. So you've got this. The key word in the first part is the incircle. So remember what the incircle is. The center of the circle is the exact same distance away from all three sides. Sorry, that was a bit off, but basically all of those are radii. So bear that in mind for later on. Now we have find SG, give your answer in terms of meters. So here we have the larger triangles and we're looking for SG here. Now we know that this angle is 68. In this case here, it's not right angle triangle, so you can't use sin, cos or tan. You do not know a pair. Remember what a pair is. It's a side and the opposite angle. So you don't know this angle, you know this angle, but you don't know this side. You know this side, but you don't know this angle. So if it's not right angled and you don't have a pair, then you have to use the cosine rule. So if I'm going to call this side A, that has to be the angle A. So it's A squared. B and C don't matter then. So 30 squared plus 58 squared minus 2 times 30 times 58 by cos 68. So I'm going to leave a lot of the working out for you guys through here because it's just calculator work. Remember to set your calculator 2 degrees. Otherwise the video will take longer than the lifetime of the universe to upload. So when you work out all of that, you find that A equals 54.4 meters. Correct 1 decimal place. Now the second part, find HSG, give your answer in degrees. So find the size of the angle HSG. So sometimes it's good practice to just draw the angle out yourself again, or draw the triangle out yourself again. Now this time, I do know, remember from the first part, that this is 54.4. So you could use the sine rule, you could use the cosine rule here, because you do know a pair. Or you know all three sides, so you could use the cosine rule, but it's easier here just to use the sine rule. So A over sin A equals B over sin B. Now remember that can be written upside down as well. Sin A over A equals sin B over B. Why do we do that? Well, I suppose it's handier when you're looking for the angle. It keeps the unknown angle top of the left. So sin X over 30 equals sin 68. So what side is opposite 68? It's 54.4. Take the 30 across and multiply, and then that will give you, when you work this all out, you'll get X equals, what is it now? Correct 1 decimal or 2 decimal places, 30.75 degrees. So take the 30 across and multiply, and then X equals sin to the minus 1 of that. Now, find the area of the triangle SGH. So that's the big triangle, the area of the triangle SGH. So in trigonometry, the area of a triangle is half of any two sides multiplied by the sin of the angle between them. So you must know two sides and the angle between. So even if you couldn't do A and B, you can actually still do this question. So you do know two sides, and the half of 30 by 58 by sin 68, multiply all of those together and you get correct 2 decimal places, 806.65, don't forget meters squared. Find the area of the triangle HSP in terms of R, where R is the radius of the helicopter pad. So this is R here. I've just left out the circle, but we can find this. Now it says in terms of R, so R must be in the answer. R is the perpendicular height, because I know the base, I know the perpendicular height, so it's half the base by the perpendicular height. Give your answer in terms of R, so it's a half multiplied by the base, which is 58, multiplied by R, which equals 29R meters squared. It's always important, and you know I do keep hitting it home, but you must always give the answer in terms of R. Now this part, show that the area of the triangle SHG in terms of R can be written as 71.2 r meters squared. So in terms of r, so basically the area of the triangle SGH is equal to the area of the triangle GPH. So this one, which I'll put in kind of shades, plus the area of the triangle HPS, plus the area of the triangle GPS. So we know the area of this, but we're asked to find it in terms of r. But of course, there's an r in each one of them here. And I know the base of this from the first part. That answer is 54.4. So that's 54.4. This is 30. So it's a half the base. So we'll look at GPH first. So a half of 30 by the perpendicular height, which is r. Now HPS next. We've already done that. We found that in this one, in part D, part 1. So that's 29 r. And then GPS, so it's half multiplied by the base multiplied by the perpendicular height. So 15r, half by 30 by r is 15r, plus 29r, plus 27.2r. So add all these together and you get 71.2 r meters squared, QED. And then find the value of r. Now whether or not you could do this part doesn't really matter. You could still have been able to attempt this part. So the area of the triangle in terms of r is this, and the area of the triangle actually is 806.65. So those two things just have to be equal to each other. So we found the area of the triangle to be 806.65. And we've also done from this part show that the area of the triangle can be written as that. So 71.2r. So just take the 71.2 across and divide and correct to one decimal place. R is 11.3 meters. And the last part, ST is a vertical pole at the point S. So vertical pole means that that's a right angle. There's an angle of elevation from the point P is 14 degrees. So if I just drew this out separately here, so that's 14, that's 90. So this will be, that angle there will be 180, take away 90, take away 14, so you get 76 degrees. And so that gives you 76 degrees. Now how can we use that? I suppose, what are we looking for here? We're looking for the height of the pole. So ideally, tan 14, it would be maybe, so say tan 14 degrees equals the opposite. So say that's the opposite, so that's T and that's S. So over the adjacent, which is PS. But I don't know any of these. So is there any other way I can find this? Well,